Hey guys, how's it going today? This is lesson 6.2, transformations. Just kind of go over some transformations real quick for you guys. Um, the first transformation here that we need to kind of pay attention to is uh, vertical translation up. If you pay attention right here, the numbers, okay? If you look at your numbers right here, they are outside of your radical, okay, or outside of your function here. And this basically what it's doing for us is it's giving us three functions that we're going to be dealing with. Okay, it gives us the square root function, gives us the cubic function, gives us the cube root function. So it gives us three different ones, three different examples. They all mean the same thing. Vertical translation up. Okay, vertical translation down, same idea. Now it's going to be -3, but again, it's going to be outside of radical or behind our function. So it's pretty simple to pay attention to. Now, the hard one is horizontal translation. So this is the one you guys kind of got to wrap your brain around. When you're doing horizontal translations, now if you notice where it happens to your numbers is, okay, your numbers go inside. So it's like x -3, but if you notice, it's underneath the radical. The thing is, though, you have to think about these backward. All right. The backward thinking, if you read right here, it says horizontal translation right 3. A lot of people would say left. Okay, well, they'll get the direction right, but they'll forget that this is actually backward. So make sure you guys understand that when you're dealing with horizontal translations, okay, these are the ones that you have to think backward on. Okay. Um, the next two, okay, vertical stretch and vertical compression. All right. When you look at a vertical stretch or vertical compression, um, if you notice where the number's at this time, the number is going to be placed in front of the function. So again, if you look right here, these threes right here, they're in front of they're in front. Okay, it says a vertical stretch by a factor of 3. Well, how do I know it's a stretch? Okay, stretches will happen when the number is greater than 1. Okay, so anytime a number is greater than 1, it's a stretch. And then it kind of goes the opposite direction for vertical compression. Again, the numbers are in front, but now the number is less than 1. All right. And so that makes it a compression. Basically, what you need to understand on a vertical stretch and a vertical compression real quick is a stretch would basically take the line wouldn't move, or the vertex wouldn't move. So real quick, I can draw a different one for y'all. So like, let's say this is a square root graph. Okay. If it's stretched, it's not going to move from 0, 0. The line would just be basically higher up or stretch higher. And then for a compression, same idea, except for now it would be pushed down or compressed. So the lines don't move. It doesn't move up, down, left, right. Okay, it just stays in the same spot. And then it's either a stretch will be on top or compression will be below. Okay. Now the next thing that we're going to talk about here, we're going to talk about horizontal stretch and compression. Okay. I'm actually taking these off, so you don't have to worry about the horizontal aspect. And then I'm doing the same thing for the reflection about the y-axis. So I'm going to take that one off so we can just focus on the things we need to. So the only reflection that we're going to focus on is when there is a negative in front of our function. So again, if you look at the negatives here, they're in front of the equation. So anytime you have a negative equation or a negative function, okay, it's real simple. It's going to be a reflection about the x-axis. All right, so that's kind of what tells us on that. Now, the way I told the kids to do the notes the other day, okay, or the way we did the notes is I went ahead. Actually, we'll just go ahead and start here. Okay, so what they want us to go ahead and do says example 2: write the equation g that results from. So what you're going to do is you're going to take this verbiage and you're going to put it into one of these equations that we were talking about a while ago. So basically the first one right here says shift f of x equals x to the third up 7 units. So what I'm going to do is I'm going to go back to my chart and I'm going to look for where it says up. Well, here's up. I find my cubic function, so I need to basically mirror this function with my number. So it'd be g of x is equal to, it'd be g of x, okay, is equal to x to the third plus 7. Again, we're not going to do this horizontal. Okay, we're not reflecting about the y-axis. Okay, so we skip those two. Okay, reflecting about the x-axis. So again, I told you guys, and you can kind of see it up at the top here, but it's a negative in front of your function. So actually, you can still see it right here. So you would write g of x is equal to negative cube root of x. All right. Same thing here when you're translating f of x left 5 units. So again, my information is going to come out there with me, so just bear with us through this part. But you're looking for left, okay? So I'm looking. Okay, I find left right here. So I know that we're going to look at this function right here. We're going to put a plus on the inside with whatever number we have, okay? So I'm coming back down. So I would have g of x now equal to square root of x plus 5. Again, I'm going to keep it inside. Okay. Now, last one, vertical stretch. So basically, a vertical stretch is now we're just multiplying this by the function. So, and again, you can go back up there and look. Anytime you get a stretch or a compression, you're just basically multiplying the stretch in front of the equation. So it's pretty simple. Okay, so this is kind of like the rundown of how to do this part. We are going to look at some graphing tomorrow. So I'll wait on putting it in the graph, but you can graph these, especially the ones that are, given to us. Okay, so I want to jump down to this practice A because it has a little bit more problems for us to kind of look at in the way I want us to kind of pay attention to these. So now what's going to happen, instead of you writing the equation from the words, they're going to give you the equation. You need to put it in words. So again, what I would personally do is, or you can graph these. Like I said, this would be F1, this would be F2, okay? But I would graph this and then graph this, or I'm gonna go look for this function right here up at the top. So it's a cubic function with a minus behind it. So again, I'm gonna go look, okay, oh, here it is, cubic function with a minus. I know it's gonna be vertical translation down, and then how many ever units is on the problem. So this one will be, I'm actually going to type it. This would be vertical translation down 9. Okay, so that's how you would do. That's how you would do that. Pretty simple. Pretty simple idea. Okay, same thing here. You would go look for that function. Okay, see where the minus, where there's a -7 in here. Okay, I know that. So it's horizontal translation or shift. Okay, this again, these are the ones that are backwards, so this would be right 7. Okay, so again, the ones that are on the inside, you gotta write them backward of what you see. All right, we wouldn't do number 6. Again, number 7 should be pretty simple. Since it has a negative equation now, I know this is a reflection. The x-axis. Again, this one right here, since it's inside, that would be left 15. Okay, we're multiplying this by 2/3. So since that's smaller than 1, okay, this will be a compression. And then basically the same idea down here. What you're doing now is you have to kind of like write the function out based off what they gave us. Then you can kind of compare it. Or if you're good at it, good enough, and y'all don't have the number 11, by the way. Okay, if you're good enough, you can kind of already tell. Well, since this is a 5 and we're in our function being multiplied, I know this will be a vertical stretch. Okay, this would be a vertical stretch. Okay. 12, same idea. Since I know it's a negative in front of the function, you can know this is a reflection. Now, if you do want to put this in the calculator, what you would have to do is you would just literally just rewrite it now. The new g of x based off the function that they gave us would be 5 square root of x. Same thing on number 12. Based off the function that they gave us, our new g of x here with that reflection would just be negative x to the 3rd. Okay, because you just replaced the function with the function that they gave us. So it's kind of like you filling it in. Same thing here. Since it's 5fx, well, fx is equal to square root of x, you just kind of replace it in a sense. Okay. All right. Now, that's pretty much was kind of what we talked about on the notes. You can do these again where you're writing an equation. So I already showed you how to do those a while ago. Okay. The ones from the picture, we didn't really talk about the picture ones, but again, you're basically just describing it from F. You're going from F to G. So again, what I would do is look for your center point. So from F to G, we moved right. So that's what you would put right here. So from F to G on this one, we move down. Okay. From F to G here is kind of what I was talking about earlier. If G is bigger than F and it hasn't moved, remember this is going to be a stretch. Don't worry about the factor right now, but we just need to kind of know what it looks like. So that would be a stretch. Again, like I was talking earlier, if G would have been underneath F like this, that would have been a compression. Okay. So just based off what you see here, that's kind of what you can do. All right. I'm going to go ahead and pull up one more thing right quick. Again, this is just the daily work, so kind of based off the things that we had already done. This is what you guys will be doing for your daily work, and I appreciate it, guys. And if y'all have any questions, just let me know.